Hi, eighth graders. This week during our Algebra 1 class, we will learn to solve multi-step and compound inequalities. These are lessons 6.2 and 6.3 in your textbook. So, to review what we learned last week, a linear inequality is an open sentence that contains the symbols less than, greater than, less than or equal to, and greater than or equal to. These inequalities can be solved by using algebraic methods similar to those we used when solving equations. Inequalities containing more elaborate expressions, such as the ones we will study in these lessons, require additional steps to isolate the variables in a solution inequality. Our objectives this lesson are to solve multi-step linear inequalities by applying the properties of inequalities. To solve in graph linear inequalities containing the word and. To solve in graph linear inequalities containing the word or. Our I can statement is I can solve inequalities by using more than one step, and I can write and solve combinations of two inequalities joined by the word and or or. The following vocabulary will be used throughout these lessons. So we have the words expressions, equations, and inequalities. And we will see what is different or what the difference is between these three terms. So first of all, an expression such as the one here, 2x plus 3. So if a mathematical sentence contains operational symbols such as the addition symbol, the plus sign or minus, times, the division sign, without a symbol that denotes equality or an equal sign or one of the other symbols for inequalities, then the statement is an expression. We can have variables, we can have exponents sometimes, there can be numbers, and all of these are joined by operational symbols without an equal sign. Next, we have an equation. So if there is an equal sign, like in the example here, it is used to show that two or more statements of this equation, like 3x plus 7 equal 19. So here, there are two or more expressions that are joined by an equal sign. And finally, an inequality is when two or more expressions are joined by an inequality symbol. So for x is less than 2x plus 9. So these are the differences between these three terms: expressions, inequalities, and equations. Inequalities can be compound when there are two or more inequalities that are connected by the word and or the word or. A compound inequality containing the word and is only true when both inequalities are true. So when graphed, the inequalities will overlap. The overlapping section that represents the compound inequality is called an intersection. The compound, well, here we have a compound inequality. So down here, -4 less than x less than or equal to 3 can be read in two different ways. It can be read as x is greater than -4 and x is less than or equal to 3, or we can say x is between -4 and 3, including 3. The first number line represents one of the expressions, so x greater than -4. We use an open dot to show that -4 is not part of the solution, and the arrow points right to show that the answer set includes all the real numbers greater than or um, greater than -4. Next, we have that x is less than or equal to 3. In this case, we use a closed dot to show that 3 is part of the solution. And then x represents all the real numbers that are less than 3. And down here, we have what we call an intersection. So these are the points of the number line where you can see by comparing the previous two number lines that they all intersect. And then when a compound inequality contains the word or, it is true if at least one of the inequalities is true. A union is the graph of a compound inequality containing or, and the solution is a solution of either inequality, not necessarily both. So just like before, the first number line represents one of the expressions. So x is greater than or equal to 1. 1, it has a closed dot to show it belongs to the solution set. And the arrow points towards the right, indicating that the solutions can include all the real numbers that are greater than, or x represents all the real numbers greater than 1. The second expression, x less than or equal to -3. -3 is included in the solution set, so we represent it with a closed dot. And x represents all the real numbers that are less than -3. And finally, here we have a union of the two number lines that were represented previously.